Hi, this is Dr. Shoikat Majumdar. Under Basic Physics course for Diploma Engineering students, we will discuss the optical lenses. It is in continuation of our first lecture of optical lenses. Already we have stated in our first lecture that this optical lenses is in submodule 4.3 of Diploma Engineering syllabus. It falls under Unit 4 of Light. The learning objective is to demonstrate fundamental knowledge and insight into physical optics and to be able to understand and solve problems related to the eye and optical instruments, lenses, their function and correction. How is the image formed by a converging lens? So converging lens, ray tracing rules. Rule 1, similarity to a spherical mirror, incoming parallel rays are deflected through the focal point. This is the biconvex lens. This is the principal axis. Now, this one is a principal focal point or first focal point. This is the secondary focal point, but second focal point. Now, when parallel rays are falling onto the converging lens, we know that these rays will pass through the focal point. Now, these parallel rays will be parallel to the principal axis and focal point is lying on the principal axis. So, any sort of parallel rays that is falling parallel to the principal axis and the light will converge at the focal point here. This is the first rule, rule 1. Rule 2, rays passing through the center of the lens are undeflected. They continue straight through without being bent. Several rays are shown as examples. Look, this ray is passing through the optical center of the lens. Now, this ray is passing through the optical center without any deviation. That means when the ray is passing through the optical center of the lens, it will not be deflected, undeflected. That means it is undeflected. Here also another ray is passing through this is undeflected. Here also another ray is passing, it is undeflected. So rays passing to the center of the lens or optical center of the lens are undeflected. They will not bend, they will not be deviated. Any number of rays may fall onto the optical center or passing through the optical center. There will be no deflection. lens tracing rule 3. The reverse of rule 1, rays passing through the focal points are deflected to exit to the axis. This is the first rule. Here, parallel rays are falling onto the biconvex lens. Then, these parallel rays are converged to the focal point. Here, in rule 3, when the rays are passing through the focal point are falling onto the biconvex lens, then after deflection, the emergent rays from the biconvex lens will be parallel to the principal axis. So this is the rule. Rays passing to the focal point, these rays are passing to the focal point and deflected to exit as parallel rays, and this is parallel to the principal axis. Major rays used in ray tracing. Parallel ray, the incident light from the object that is parallel to the principal axis will be refracted, passing through the principal focal point after passing through the optic axis. Here is the example. So this is the principal focal point, this is the secondary focal point. This is the radius of curvature of this convex or this arc of the convex lens, and this is the radius of curvature of the arc of this convex lens. So this is 2f dash, this is 2f. Now any object placed outside the radius of curvature of the lens, then parallel ray falling onto the lens, it will pass to the first focal point. This is what here it is stated. The incident ray from the object that is parallel to the principal axis. This is the incident ray from the object parallel to this principal axis will be refracted and passing to the principal focal point. This is refracted and passing to the principal focal point. After passing through the optic axis. This is the optic axis. After passing through the optic axis, it will pass to the principal focal point. This is the parallel ray. Focal ray. The incident light that passes through the secondary focal point will be refracted parallel to the principal axis. When the ray of light passing through the secondary focal point falling onto the optic axis, so after refraction, this light will be parallel to the principal axis. So this ray will pass to the principal axis. So this is stated here. The incident light ray that passes to the secondary focal point will be refracted parallel to the principal axis. So this is parallel to the principal axis after the refraction from here. Optic ray. The incident light that seems to pass So the optical center will not be refracted. Previously, we have discussed this one. Again, we will discuss this one. This is the light that are passing to the optical center will not be refracted. There will be no deflection. So let us come to this point. The incident ray that seems to pass to the optical center will not be refracted here. This is optic ray. Light, this is object. Light is coming from the object and passing to the optical center. Then there will be no deflection. This is the optic ray. So optic ray will not be refracted. Optic ray will not be refracted. Now how image is formed? So if this is the object, then optic ray coming from the tip of the object, it is falling, it is passing along this direction. This is the green one. Focal ray that is coming from this point, passing to the secondary focal point, it will be refracted and parallel to the optic axis. So they will intersect at this point. Parallel ray, this will fall on the optic axis. Fall on the optic axis, it will be diffracted and pass to the first focal point or primary focal length. Then these three will intersect at a particular point and the image will form. This is the image. So this image is inverted. Size diminishes and it will produce in between F and 2F. That means if an object is placed outside the 2F and light is falling onto the biconvex lens, then the image will be formed in between F dash and 2F dash. It will be inverted, size is diminishing in size, that means smaller in size. This is the formation of image. Diverging lens, that means the lens will diverge the rays. This is a diverging lens. So this is a biconcave lens. We are taking a biconcave lens. In diverging lens, parallel rays are deflected such that when extended backwards, they appear to be coming from focal point on the other side. That means this is the parallel ray. It is made to fall on the one surface of the biconcave lens. Then after refraction, it will follow this path. This is already discussed because light is coming from rarer to denser. If we draw the normal, then what will happen? The light ray after refraction, it will bend towards the normal. Again, the light ray is coming from denser to rarer. So if we draw the normal, then the light ray will bend away from the normal. This is the normal, it is away from the normal. So it is going outside, diverging. Again same, this ray will also diverging. So if we extend backward, this one is, if this ray is extended backward, then it looks like these rays are coming from this focal point, from this secondary focal point. If it is primary focal point, this will be the secondary focal point. So in diverging lens, parallel rays are deflected such that when extended backwards, they appear to be coming from the focal point of the other side. This is one side focal point, this is another side focal point. So as it is extended backward, it looks like that these rays are coming from this point F. How is the image formed by a diverging lens? Ray tracing. Parallel rays are deflected, so they appear to be coming from the focal point in front of the lens. So, if parallel rays, parallel to what? Parallel to the principal axis, is made to fall on the surface of the concave lens, then according to the rules, it will be deflected along this direction. That means it will diverging one. So if this ray is extended backward, then it looks like it is coming from the point F. So parallel rays are deflected, so they appear to be coming from the focal point in front of the lens. This is the lens. Its focal point is here. It looks like that it is coming from this focal point of the lens. Just like converging lens, rays that pass to the center of the lens continue undeflected through the lens. That means any sort of light passing through the optical center or center of the lens, it will be undeflected. There will be no deflection or there will be no bending. The light will pass as it is coming in the direction, it will follow the same direction. Rays that, if extended, would pass through the focal point on the other side of the lens are deflected to be parallel to the axis. Now, any ray that is falling not parallel to the principal axis, then it will be parallel to the principal axis after passing through the lens, and the emergent ray will be parallel to the principal axis. So ray that is coming from this direction, it extending this ray, it looks like it is falling onto this focal point F dash. So this ray after refraction on emerging from the biconvex lens, the original ray will be parallel to the principal axis. Major rays used in ray tracing. Parallel ray, the incident light ray from the object that is parallel to the principal axis will be refracted as if it came from the secondary focal point. This is the parallel ray. Next one is this. Outside 2f, this is the object. It is parallel to the principal axis. It is going divergent. If we extend, it looks like it is coming from the focal point of this lens. Focal ray. The incident light that seems to pass through the principal focal point will be refracted parallel to the principal axis. The focal ray. This is the light. This is the light. It is refracted parallel to the principal axis. If we extend this ray, it looks like it is falling onto the first focal point. So this is the focal ray. So focal ray is the ray that is parallel to the principal axis. This is here. The incident light ray that seems to pass to the principal focal point will be refracted parallel to the principal axis. This light seems to pass to the principal focal point. It will be refracted parallel to the principal axis. Optic ray. The incident ray that seems to pass through the optical center will not be refracted. So this is the image. This is the object. So light that is passing through the optical center, it will not be refracted. There will not be any deviation, any sort of deviation. This is the nature of the optic ray, or this ray is also known as the optic ray. So these are the ray tracing of the diverging lens. Come to this figure. How the image is formed. This is the object. So parallel to the principal axis, this light is going this direction. It looks like it is coming from the point F. Now this light directed to the focal point F dash. So this one will be, after refraction, parallel to this principal axis. Now this ray, if we extend back, it will intersect the extension of this ray at this point. If the ray directed towards the optical center, it will be undeviated. So these three rays, this extended one, this yellow, and this extension of this red, and this green light will intersecting at this point, and it is producing the image. The image is produced in between F and the optical center of the lens. Size is diminished, and this one is erected one. This is the erected one, not inverted. For that case, to initial case, for the biconvex lens, we have found this is produced in between F and 2F dash. This one is inverted, but here it is erected. For the diverging lens, that means biconcave lens, the image is erected. Similarly, size diminishes and it is produced in between F and the optical center of the lens. This image is a virtual one because this cannot be produced on the screen. This is a virtual one, but here the image is the real one. In case of convex lens, in case of convex lens, this is a real image, inverted, diminishing size. Here, for this condition, outside 2f, the object is outside 2f. This is the real image, but here this image is virtual one. This is a virtual image. Virtual, reduced, and right upside. Right upside means this is erected.